let's make an object that we can control in terms of its position using some code.
Yep.
Okay, so let's make, I can right click in the hierarchy. I'll go for a 3D object, and we could go with a sphere. And I'll call this ball. Now my balls, the ball is really, now wishing you didn't call it ball, but anyway. Anyway, so the ball is over in the distance here for me. What I can do to get a better view of it in the scene is I can hit F. I think of it as F for focus, and it sort of zooms in.
Oh yeah.
So that's a handy thing. Now we'll see its position. It's almost 1 off in terms of the Y position, and if I sort of look at it, it's actually hovering a bit.
Mine's way off the ground. Mine's 5.
5. Okay, so if we make it 1, actually it depends on its radius. So because its whole scale is 1, this is about, probably if I want to make it a 0.5, and it should be exactly on the ground. So the whole diameter is 1 meter, so that means the radius is 0.5. So
Done something wrong.
Done something wrong?
Right.
Do you want to share screen, or?
It's disappeared. I typed in 0.5 and it disappeared.
Oh, where did you type 0.5, in the Y or?
In the Y in position.
I tell you what, click on the scene view, anywhere in the scene view, and then hit, actually no, sorry, take it back. Click on your sphere in the hierarchy,
Yep.
drag the mouse over the scene view and hit F for focus again. See if that helps.
Oh, it came back.
Yeah. So it probably just disappeared out of view because you're quite zoomed in. When you hit F, it sort of zooms you in. And so if you make the object sort of disappear, oh, I know why, because you said it was really high off the ground. So your camera would have gone, when you hit F before, it would have gone high up, and then when you made it 0.5, it would have dropped down out of your view.
Yeah, it looks like I'm looking underneath the surface now.
Okay.
So how do I?
So, well, if you click on your plane,
Fixed it. Middle mouse
zoom.
wheel.
Yep.
Middle mouse wheel. Yeah, I'm back on track now.
Ace.
No.
Nice. All right. Okay, now we could create it's a sort of grey colour. We could create another material for the sphere. So, like before, right-click in Materials folder, create material, and I'm going to call this ball mat. This one I'm going to leave metallic. Let's see, I'll make it sort of an orangey yellow, and let me drag ball mat onto, I can drag it into the hierarchy. So last time I dragged it into the scene, but I can actually just drag it in here and it does the same thing, and that's more precise because you could accidentally drag it onto another object when you go over through the scene view. So now it looks almost like clay or something, because its metallic is right down to 0, but if I drag that up, it starts to look sort of shiny and more like a polished brass ball. And I can change how smooth it is.
Oh yeah.
We can look.
Cool.
Yeah. So now it's more like a shiny brass ball. Okay, so why don't we create some code? So it's good to organize things. So in the assets folder, I'm going to right click on that and create a folder. I'm going to call it code because I don't like calling it script. I don't, C# is a compiled language, dang it.
Yeah.
So, all right, now from here I can double click on code and it will take me in, or I could have clicked, on the left here That's just a choice. So now I'm in the code folder. I'm going to right click. I'm going to create C# script. And we'll call this, why don't we use sinusoid, to change the height of the ball, to make it sort of move up and down.
What was the word you said?
Sinusoid, like sine, cosine, tan, that sort of thing.
Oh.
From good old mathematics.
Yeah, I know.
Trigonometry. Yeah. So we'll just call this Autobounce. And if we double click on it, double click. If you hold click, it'll go to renaming. Reload. Because I had files open before, I had to reload, but anyway, that's fine. So now we can see we have a template C# file.
Yep.
And it's got the Unity engine namespace being used here. We have a thing called Autobounce class, which implements monobehavior, or extends rather the monobehavior class. Monobehavior is a class in the Unity namespace that, and we could look it up actually in the scripting reference. So if I go back here, scripting reference, and actually let's try check into the search monobehavior, and they actually spell it the proper English way, which is kind of nice. So now we can find the monobehavior base class.
Yeah.
And we can see that it has certain properties, and they have these certain methods. So, okay, here, if we look at if I sort of Alt-Tab back to Visual Studio, we can see here that we have a start method and an update method that the template gave us. And if we go back here, we can see they talk about these methods on monobehavior.
Mm-hmm.
So they all have special meaning, and Unity, if that method exists, it will use it, right? So basically, when the scene starts, it'll call the start method and do whatever it needs to do there. That's kind of like a constructor. So you can use that to set things up. There's actually a few different methods. There's another one called awake, which you can also use for that. There's update, which basically, and I can click on that and it'll tell us about update and give us some sample code. Update is something, every frame, so you know how in a game you've got frames per second, like it's redrawing the screen all the time? Update gets called as part of that frame draw.
Oh, yeah.
Right, so there's actually a whole pipeline of work that it does. It'll call update, so you can do things like you can change its position, change its rotation, and you can do other things. You could potentially apply a different material to it and make it look different. So you could change these things, and then through the pipeline, it'll go and do a render later. So it does this whole process. And there's another thing called fixed update, which is basically for the physics engine uses fixed update, and that happens in regular intervals. So we can. Sorry, if I go back to here, so back to Visual Studio. So here we can create properties that we can edit through the inspector, and we can use that so that it's easier to configure our object. And we can then set things up so our motion, like I said, we're going to make the ball move in the y-axis just regularly using the sinusoid over time. So, so that's what we'll do, right? So yep. Now what we'll do, if we think of sine, cosine, the regular maths functions, with sine it, in fact, they even have that in here, math dot, under classes they've got some of the base, they did have, if I collapse this, under other classes, they have some sort of base, some documentation for normal C#, some normal C# stuff. Actually, that's all changed, it seems. All right, accept all cookies. I don't know why I'm accepting cookies for something that's locally sourced, but anyway. Actually, it's not here anymore. Okay, that's interesting. Do I have to click on other? Okay. It's changed. It was here. All right, never mind. I'm going to click on Unity Engine and leave that there. Sorry, back to... So anyway, math, as you know, math sign will basically for different angles we'll get values between 0 and 1. So we can make the ball hover from an offset of 0.5, because 0.5 means it's on the ground, and then we can make it move up a whole 1. So then its y-axis will go from 0.5 to 1.5, and then that'll give it a little hop. And then we can add a bit more logic to it, or a bit more code to it, so we can actually, through the editor, change how big we want that that to be, that oscillation. Okay, so what we can do here is, as good programmers, we can do const. I want to make an offset just to represent that sort of base. So I'm going to make that 0.5 f. So that just that base. Now the other thing we can do, so Autobounce will become a component. We can get references to other components from the game object it's attached to. So remember, transform is a component, and every game object has one. So we can get access to that. So here I can have private transform, right? That's the name of the class that I want to get, and I use underscore as my prefix for private things. Transform, and then what I can do here is I can do underscore transform equals get component, and they use generics to indicate which kind of component I want. So I'll wait for you. How you going?
Good, nearly there. Slow typer after all these years, yep.
Yeah, no, that's all right.
Yeah.
Now, I might zoom in a smidgen just to make sure that's easy to see. So what this means is when the scene loads, right, or when the game starts, this method will get called, and this is why I said before this is a bit like a constructor. At this point, it will do a lookup using getComponent and find the transform component that's already attached to the game object, and it will store a reference in this variable, right? And we'll use that to change the position.
Yep.
Now, okay. In terms of actually no, that'll do. So we've got that. Now we can change its position from the update method, like I said, every time it draws. This is where we can change its update. Now, there's a thing when it comes to time. With games, the more you have going on in the scene, the actual render time changes. The time to actually draw the scene changes as things get complex. So what we can do is we can come up with an angle. I'll call it time angle because it's really an angle over time that's changing. So let's do a float time angle as a local variable, and I'm going to use, they have a thing called time.delta time, and we can multiply it by some factor to say how fast we want it to be. That time.delta time, the delta time property is the time it took between, in milliseconds, no, it might be a second, it's a fraction of a second, since the last render to the current render. So if you want to make things smooth, then you need to multiply it by time.delta time. Otherwise you could get jerky. As the scene gets busier, it will kind of get choppier and look a bit laggy at times. So this makes it nice and smooth. So now what we can do is we can have, we can have float. We're really changing the height, so we can say height will equal base plus timing. Sorry, take a step back. Actually, no, I was right. Sorry, base plus Now I want sign, so math, I think it's mathf dot sign, that one, sin, sign, yeah, time angle, good old Visual Studio 2022's got some nice prompts, autocomplete. So this will give us compute a new height for us, so the 0.5 as our fixed bottom, plus this change of position over time, by treating, and that should be in radians, I think, from memory. Anyway, okay. So now what we can do is we want to change the actual position. Now, the easiest way to do that is we have a vector 3 represents our 3D place equals transform.position. There's a couple of ways we can do this actually. Vector 3, so I should give that a variable name, that would help. Pos. So I'm getting like a snapshot of the current position. And then I want to change, this is too good. IntelliSense is guessing exactly what I want to type here. So pos.y, I just want to change the y component to change the height.
Yep.
And now we set that back into the transform, and again it's gone and guessed it for me. So underscore transform dot position equals pos.
Yeah. Did you say that was 22? Did you?
Sorry, 20.
Is it Visual Studio 22?
Yeah, 2022.
Okay. Pretty clever.
Yeah, it is very clever. It's machine learning based and all this sort of it's fairly spiffy. So there's another way we could have done this. But let's see this work first, and we can worry about alternate ways of doing it. Okay, so now we can save this. So I do Control S and I'll save it. And if we go back to Unity, so Alt Tab back to Unity, okay, it actually compiles the script. So it actually compiled the C# code. And now I want to add that.
I don't get any feedback, but anyway, I'll see.
Oh, that's fine. Well, if you make an error, you'll see it in console. Actually, the console window is not open. We should open that. So go to Window, Console. Where are you? Hiding under General. Yes, General Console. And there's actually a key shortcut, Control-Shift-C. Now that's appeared as a floating window, so I'm going to drop it to the bottom here. Now, if you had errors, they would you'll get warnings and C# warnings and errors appear in the console. So we can prove that. Just to prove that, I'll just type the word spooky here and then save it, and we should see a nice C# error occur. Error, invalid token.
Okay.
So if I get rid of that now, clean up, and then come back, that should go away. And there we are. Okay, so cool, we've got our C# code. Now I can click on the ball in the hierarchy, and I can click Add Component, and it will be, it might be under Miscellaneous. It is not. Where's it gone? It might be, is it under New Script? No. If this New Script one at the bottom, if I type a name here, it'll actually create a whole new template script, like a whole new C# file, which is not what we want. Scripts, is that where it is? Yes, that's where it is. Okay.
Okay, components, script.
Now we can actually change that. There's a way we can add an attribute to our C# code, so we can have our own sort of these sort of menus. We can actually make our own one, which we'll do that in a sec because it's kind of cool. Okay, so now when I add that, it should appear somewhere. Autobounce, there it is. It's the last component in this list of components. And you can see there's a few things going on in terms of components. We have the transform at the top. We have a thing called a mesh filter, and that's linked to this mesh renderer, which is, and actually the mesh filter is linked to the mesh, actually, so that's what makes it round. So that's a built-in mesh, and then the mesh renderer is linked to the material, which has the ball mat. So when we drag the material into the hierarchy or the scene view, it's actually changing that property for us. So, and then there's some features on how shadows are cast and things like that. We can collapse these so that they're out of the way, and there's a sphere collider that's automatically added. just so you can see what's there. And we have our Autobounce script. Now, if we did everything correctly, if we hit play, we should see that thing move. So I'm going to hit play. Now, the camera is seeing it a certain way. It's moving, but it's moving.
Oh, it's disappeared.
It's barely moving. Yeah, it'll be based on where your camera's pointing. So let's stop, hit play. If we click on the camera, we can make sure the camera is probably a bit closer, so it's miles away from my sphere. So we can bring the camera closer. If we hit the Y axis and zoom out a bit, we can kind of see where the objects are in relation to each other.
Oh, there we go. Okay. Yeah.
So if we can do two things. We can, if we look, my camera is the default position for the camera. It's 1 off the ground, and it's at Z minus 10. I could bring the ball closer to it. That's probably the easier way. So I can bring it to Z sort of 5, and I might center it in the x-axis by making it 0. So you can see the camera. Hang on, let me zoom in a bit. The camera is below it here, and the sphere is there. And if I click on the camera, we can see that the camera is able to see it because the camera appears in this little view window thing.
What view are you on there?
This is the scene.
Y.
The scene window. Yeah, I clicked on the y-axis, so it looks directly down.
Let's make my camera disappear. Can I put my ball in the same spot as yours? Can you click on your ball?
Mm-hmm. Yeah, so mine's at
0.
Yeah, 0 in the x-axis, 0.5,
0.5,
and then Z is 5.
5.
And then if you click on your main camera, right, so I clicked on my main camera, so that's
Yeah.
0, 1, minus 10, which I think is the default scene. 0, 1, minus 10 is the position.
Oh, okay, I'm a different, yep. 1. Minus 10.
And then hopefully...
I can see the ball, yeah.
You can see the ball, yeah, ace.
Yeah.
All right.
Now push play.
So if you hit play, so let me... yep, that's fine. So we can hit play, and that'll take us back to the game window when it's running. There we go. The ball is actually moving, and we can tell that if we click on ball in the hierarchy and look in the y-axis, it's moving, but hardly moving at all. So
I can see. Oh yeah. I can see mine vibrating.
Okay, yeah. So let's multiply. Let's add a factor to this thing so that it's sort of more visible. So if we go back to Visual Studio, and if we, so here, like I said, it should be between 0 and 1. This time angle number is probably, you know what, I should probably multiply this by pi. Now that I think about it, that's probably a smart move. Mathf pi times, that would probably be a bit smarter. Let's see that difference. So in terms of time angle, and then it will be in whole radians. I'm fairly sure, I can look it up, but I'm pretty sure that's in radians, the standard C# mathf function. So yeah, compiling. So if we try now, hit play, it should no. No.
Mine is. You can just see it vibrating and bounce a little bit.
Okay. All right. So we can multiply sort of an amplitude around the sine thing here. So if we just call it 10 times mathf, like mathf.sine, so we sort of multiply it by 10 to give it a bit more of a bigger amplitude.
Plus 10, right, yep.
Yeah.
Yep.
And then if I go back to Unity, it should, okay. Yeah, sometimes it compiles so fast you don't see it. Okay, so now if I hit play, it should be a lot more visible. Okay, now mine's vibrating like a crazy thing.
Yeah. Oh, cool.
Yeah. Now what we can do is let's create, so this amplitude thing, let's create a property that we can edit in the editor through the inspector, and we can make another factor for the time angle, and that'll give us, we can change the frequency, and then we'll be able to change like the amplitude of motion. So let's go up here, and we can do this a couple of ways. One way is to create public variables. So if you make public variables, the Unity inspector can see it. So we'll make this a float, and we'll call this amplitude, and we can give it a default value as well. So I'll give it a default value of 1, and then public float, and it's really like I'll just call it angle factor, because I can't think of anything more creative. I'll give that a default value of 5. And then if we go down to time angle in update, and we multiply this by angle factor times, and then down here I'll get rid of 10 and I'll replace that with amplitude. And if I save that, and I'll check in with you, how'd you go? Let me know when you're ready.
Save. Going back to Unity.
Back to Unity. And now, in the inspector, we should see amplitude and angle factor.
Oh, yeah.
And notice, because I had angle factor, if I switch back to Visual Studio, you can see here it's angle factor, sort of capital camel case.
Yeah.
Right? But notice here they're smart enough to put a space between it in the in the property. So now we can change the amplitude. We can actually hit play, and we can edit this live. So, for instance, I can put in 100, and now it's going completely nuts. And I can change the angle factor live.
Oh, wow. Yeah, it's gone crazy.
Yeah. Actually, let's make it 0.002. Does that... that slows it right down. 0.02. Okay, 0.2. Okay. 1.5. 1. Okay, I'm just trying different angle factors. 3. Yep, now it's pretty mental. And it depends how quickly, everything can catch up. So, yes.
It's a really neat environment.
It is, isn't it?
Like, if you want to work out the right value, you can just, like the ripple with, what's that, Erlang and stuff like that, you can just try something, change it in the edit and see what impact you get.
Exactly. Yeah. So it means that you can actually write code, you can write components that then you can do like your game design with, which is a very cool thing. So the whole idea with the inspector and the editor and the scene view and the hierarchy, you can actually do your game design, and you can write components so that they can be designed, more easily. The other thing, if you want to know what your statistics are like, there's on the game view you'll see next to mute audio there's stats. And if I click on that, you can see what kind of FPS we're getting. And it's going fairly crazy. I'm getting about 600 to 700 FPS.
I'm getting 100.
Okay, well that's nothing wrong with that. That's quite decent. And that'll vary with graphics card and whatever else that's going on. Yeah, and so we can turn that off. So you can use that obviously for tuning. Yeah.
That's cool.
Yeah.